In this lesson, we are going to learn about three things: elastic after effect, elastic fatigue, elastic hysteresis. What is elastic after effect? The delay in regaining the original shape and size after the deforming force is withdrawn is called elastic after effect. This scale is there. We apply a deforming force. Now it takes some time to come back to its original size and shape. This is called elastic after effect. Quartz and phosphor bronze, they have got very low elastic after effect. That's why they are used in galvanometers. You deform them, they come back to the original state very quickly. So that is, elastic after effect is small. Some things like glass fiber, they have got a very high elastic after effect. Right? If you deform a glass fiber, it takes a lot of time to come back to its original size and shape. So this is elastic after effect. The delay in returning to the original size and shape, original state after the removal of the deforming force is called elastic after effects. Elastic fatigue. What is this? Suppose we give it this scale, alternating strains. So I keep on doing like this. After some time, this scale will break. Right? The loss in strength of a material due to alternating strains is called elastic fatigue. Suppose you take a wire and you give it alternating strains. Then after some time the wire breaks. That is called elastic fatigue. What is elastic hysteresis? Suppose we make a graph of strain versus stress, or stress versus strain. Stress strain graph if you make. Then as we increase the strain or the stress, the graph goes like this. While coming back, it goes like this. The stress strain graph is not retraced while reversing the strain. While going, you go like this. While coming back, you go like this. So this graph is not getting retraced or reversing the strain. This is called elastic hysteresis. And this area enclosed by this graph gives us the energy lost per unit volume in the loading unloading cycle. So you go from here, increase the strain, then decrease the strain. In one full cycle, whatever is the energy lost per unit volume is given by the area enclosed by this graph. Right? So this is what is elastic hysteresis. The fact that the stress strain graph is not retraced while reversing the strain is called elastic hysteresis. And the area enclosed by this hysteresis loop, that gives us the energy lost per unit volume in the loading unloading cycle. Now, some places you want the energy to be lost. Right? In shock absorbers, you want them to have a large area hysteresis loop so that a lot of energy is lost, right, in this loading unloading cycle. In some places we don't want the energy to be lost, right? We don't want heat to get produced. Like in a car tire, right? There'll be loading, unloading as the car travels. Not much heat should be produced in this process. So car tires are made of synthetic rubber which has got a small area hysteresis loop. And because of this, the car tire does not get heated in a journey, too much heated, right? Shock absorbers are made of vulcanized rubber which has got a large area hysteresis loop. So a lot of energy get dissipated as heat in a loading unloading cycle. So remember this about elastic hysteresis. The fact that the stress strain graph is not retraced or reversing the strain is called elastic hysteresis. The area enclosed by the graph gives us the energy lost per unit volume in a loading unloading cycle. Car tires are made of synthetic rubber which is having a low area hysteresis loop, right? And because of this, the car tires do not get heated too much in a journey. Shock absorbers are made of vulcanized rubber which has a large area hysteresis loop, so a lot of energy get dissipated as heat, right, in these shock absorbers. Shock absorbers are made of vulcanized rubber, car tires are made of synthetic rubber. So I've learned about elastic after effect, elastic fatigue and elastic hysteresis. Elastic after effect means the time delay in regaining the original size and shape after the removal of deforming force. Quartz fiber and phosphorus bronze have low elastic after effect. They come back to the original size and shape quickly. They are used in galvanometers. Glass fiber has got a very high elastic after effect. After deformation, takes a lot of time to come back to its original size and shape. Elastic fatigue means loss in strength of a material due to alternating strains, right? If we keep on doing this, the scale will break. That is elastic fatigue. Elastic hysteresis means the stress strain graph is not retraced on reversing the strain. The area enclosed by the hysteresis loop gives us the energy lost per unit volume in a loading unloading cycle. Car tires are made of synthetic rubber which has a low area hysteresis loop. Shock absorbers are made of vulcanized rubber which has a large area hysteresis loop.